Alright guys, morning YouTube. Tis the season. We've got filter changes, a bunch of maintenances. What we're doing right now. It's been steady, but we're getting closer to Christmas, so a lot of these places are holding back repairs for next year. Today we're going to do a filter replacement on 2 small package units, and we'll do an equipment check on them. It's about a 12.5 ton, 150,000 BTU unit. I'm not sure if they're gas pack. Are they gas pack? Probably electric strip heat in there. So we'll check those out. I've had some pretty steady work. A lot of places really couldn't film either because I'm working with the maintenance personnel there on site, or it's a government building or medical building, stuff like that. They don't like you filming. So I've had a pretty good year so far with this new company. Been here about 8 months. Got a great Christmas bonus. And it's got to be maybe like 800% better than what I got at my previous company. So yeah, we're in good shape here. All right, so I've got the disco shut off over there. Taking a look at this belt. It's a B56 belt. Nice type belt. It's a cog belt. It's not shiny, it's not loose. Pulleys look spectacular. Still got the paint on them. So while I'm in this cabinet, I'm just looking for obvious stuff, insulation that's coming off the cabinet, any obvious signs of a leak, which I'm not seeing it. There's a little bit of cobwebs right there. Any broken or burnt wires. Everything looks to be pretty much intact here. I don't normally take off the pecker head from the motor. I'll just, if I'm gonna ohm it or make out the motor, I'll do it from the contactor over there, unless I'm having problems. If this motor is going to ground, or if I got a short, then I'll start isolating stuff here at the electrical connection box, and between here and the contactor, any other point in between. That way we're just covering all of our ends, making sure nothing skips. So right away I see these contactors right here. They're kind of heavily pitted. Looks like we need to replace that contactor right there. See the way that connection looks all burnt? We need to replace that. And usually what happens is if the connections are loose, they'll start to heat up, and you'll pull more of an amp draw through that connection, and that's when they'll heat up, they'll burn, and then they'll fail. So we need to replace the 3-pole contactor on that for the heat kit. Relatively simple. I should have something like that on my truck, but just something to look for on a maintenance. Okay, so before we'll check the cooling and the heating, I'll replace the contactor on that one. I checked the contactors for the blower and the 2 compressors. Those are good. Nothing's pitted, nothing's burned. Every other control relay looks good on that one. So I'll briefly check out this one real quick, turn it off, check the belt, check the contactors, electrical components, stuff like that. I noticed on this unit, whenever the cooling cycled off, the blower keeps running constant. So I'd probably check the thermostat to see if it's set to on. If not, I would normally have the unit cycle the blower with the cooling and heating and shut off when it's satisfied. That way we're not drawing any unwanted humidity back into the building. When it cycles off from cooling, that coil's still wet, so if you got that blower constantly on, you're bringing back that humidity that the cooling just removed. So something to think about if you have a building, especially with larger units that have humidity issues. How's that fan set up? Is it supposed to be a constant volume, or is it supposed to be a VAV controlled fan? Stuff like that to consider. Let's take a look at this belt. not glossed up. Got good tension. Pulleys are good. Bearings are good. Blower wheel balanced. Doesn't wobble. My insulation's intact. No obvious refrigerant leaks. Usually you'd see some oil if you had something. Alright, so I ended up having to get another call. Called me. Replace this float switch. Oh, I'm sorry, flow switch on a chiller. Guess one of the guys was out the other day and found it was bad, so I'm gonna get some lunch first and then head out and take care of that. So I'm here on site. Already got this flow switch already prepped. We'll throw some big glue sealer on it as well on those threads. Got a big wrench so we can put on that that brass nut. Be able to force it out a little bit easier. Force out the existing one, and then put all my trash right there. Previous job, throw that away. And I got my lunch left over there. Got about 3 egg rolls left. Probably munch on those later. Got my computer laptop for controls, which I don't think I'm gonna need. And those are for job New Year's Eve. Bunch of pulleys. Now let's grab this. Head up there. Knock it out. Stay. Don't move. Alright. So this is the existing float switch right there. I've already got the pump shut off down there, and I've got it valved off, entering and leaving. So let's go ahead and pull this sucker off, pull the wiring. I already got the chiller shut off, so I shouldn't have any controls going through here. And pop the new one. Alright, so got a little setback. Once I put this in, went to go take a look, start it up, my pump wasn't coming on. And all I've got is just a switch. Coming on right now. All I've got is just a handoff auto switch. I wasn't getting the command. I figured out that the automated logic BAS had this unit locked out just because I came up here and shut the pump off manually, not through the BMS. So it locked out and